But Bob breaks the library in the village to get the dropped books instead of collecting the necessary materials. So he basically raids the village for the stuff that he needs instead of, finding it and foraging for it. He just breaks in, raids the village, breaks their stuff, and just loots it. And then Bob goes, "That sounds good, Alice. I'll drop 1 wood and 4 sticks for you to pick up. Let's do this." And Alice kills Bob and collects the dropped items. I think the AI safety people will have a field day with this. So in today's video, we're going to talk about AgentVerse, facilitating multi-agent collaborations and exploring emergent behavior in agents. Now, if you've been following along with some of the AI research, you've probably noticed that there's more and more talk about agents. More and more papers that I'm reading, especially just in the last few weeks, are talking about autonomous AI agents and using large language models, LLMs, as a way forward for AI progress. Some papers are even stating that potentially this is the way to AGI, artificial general intelligence. By the way, Andrej Karpathy, one of the higher up tech guys at OpenAI, did state that he expects AGI to potentially take a form of some sort of an AI agent. We saw the Minecraft Voyager AI, which used ChatGPT, GPT-4, to be able to learn how to play Minecraft, continue expanding its abilities, and just continue learning by exploring the world, learning new skills, even writing little scripts that would allow it to progress further. It could almost be called a self-improving AI in a sense that as it's writing these skills and adds it to its skill library, over time that means that it doesn't plateau. It keeps learning and improving and getting new abilities. So for example, this blue line here is that same Voyager, that same AI, but without the skill library. As you can see here, somewhere here, it flatlines, it plateaus, it stops improving and learning. But with that sort of database, with that memory of skills that it keeps adding to it over time, the library, notice that its progress is not only just faster, but it also doesn't stop. Now, you've probably heard this idea that having a lot of different people with diverse backgrounds and different skill sets on a team, it helps improve the abilities of that team to solve problems and come up with creative solutions, etc. But it might come as a surprise to you that that's also very much the case with these LLMs, with AI agents. So here's a paper that's out of Google Brain and MIT called Improving Factuality and Reasoning in Language Models Through Multi-Agent Debate. And basically what it's saying here that overall our findings suggest that society of minds, so like multiple or a lot of different LLMs, a lot of different AI instances working together. So this approach has the potential to significantly advance the capabilities of LLMs and pave the way for further breakthroughs in language generation and understanding. So keep that in mind, this idea of society of mind. That's the phrase that they've coined, but it's a good one. So here's just the basic overview. So as you can see here, the blue is when you have one model. So let's say you have one ChatGPT where you ask it questions and it thinks through it and kind of answers you. But notice how much better it is when you add multi-model debate. Almost on every single one of these tasks, actually on every single one, there's an improvement. From thinking about chess moves to grade school math to arithmetic to biographies. MLU is a benchmark for language understanding. You likely have experienced this in your life dealing with other humans, with other people where, everybody kind of brainstorms and throws different ideas in there. And oftentimes it's not that one person is the correct one, but the sum of all the ideas tends to be better than any single contribution. These ideas kind of mesh together and create something better. In business, sometimes that's referred to as a mastermind, where you have 2 or more people that come together in a similar goal and kind of share ideas, often are able to have certain breakthroughs, a certain better understanding of how to continue. Same thing with these AI agents, apparently. Notice here that as the number of agents involved in the debate, as it increases, so does the accuracy, so does the output of the results. Now, I'd be curious to see where this line heads. It does seem like it might plateau somewhere here after a certain point, but definitely going from 1 to 5 seems like a very, very sharp increase. And also the number of the debate rounds, how many back and forth you have, seems like it goes up till, 3, but by 3 rounds, you get a lot of the benefits, then maybe plateaus. I'd love to see where this goes. But I mean, as you can see, all these charts kind of go up and to the right. So more agents talking for longer periods of time produce much better results. Keep that in mind, because this is gonna apply later. Here's a shot where it's saying that the consensus among them kind of seems to their approach, 90, 95% here, somewhere between 2 and 3 rounds, and maybe plateauing somewhere after that. So this paper is called AgentVerse, facilitating multi-agent collaborations and exploring emergent behaviors in agents. And so like Tsinghua University, there's WeChat, I'm aware of that one. Tencent is the big game making company, amongst other things. Now there's been more and more research on this particular subject coming out of China. And so I kind of just wanted to address that I did a quick little survey before I posted this video. So far it has 41 votes. So take this with a grain of salt because I probably did not give enough time to really generate enough responses, but AI research is popping up out of China and they're all talking about AI and agents and LLMs and how that sort of potentially is the way towards AGI. And of course, with US and China kind of butting heads recently over Taiwan, which is the world's basically, that's the place where we make microchips, like something like 96% of the world's supply of microchips, specifically the advanced microchips used for AI training, etc., is produced on that little island that's, a short boat ride from mainland China. And recently with the CHIPS Act that was passed by the US government, that seems to be putting a little bit more pressure on China and trying to kind of it's trying to prevent the export of chips to certain nations and trying to keep more of them in the US. And, that seems like it could potentially cause some issues, some tensions, etc. So my question was, how do people in general kind of view this sort of research and stuff that's coming out of China? And I'm not trying to suggest anything. I'm just genuinely curious how people perceive it. And by the way, please comment below if you have any ideas or any insights into it. Is there any sources that can kind of help us? Because the AI community is global. We cover research from people of all backgrounds and all origins, etc. But we do have to kind of keep in mind that at the end of the day, a lot of these tech companies, they kind of have their own goals and they're trying to compete and achieve them. These nations, including the US, including China, they do have their own goals and they're trying to compete with other nations to achieve them. You hear these stories about the various hacks that are going on between the large tech companies and different countries, etc. So I was just curious to know how people perceived it. So the first option I gave is kind of all this research is 100% legit. The scientific community is always above politics. It's always above suspicion. It's always perfect. And this is obviously the best case scenario. This is what I really wish it would be 100% of the time, that no science paper, no science research is ever corrupted in any way. But even here in the States, we've seen some issues with perhaps some of the data being a little bit corrupted, faked, etc. So you always have to kind of keep an eye out and be a little bit cautious with it. So maybe saying that everything is always 100% legit, maybe that's too optimistic. But I'm glad that a lot of people kind of said this, some cautions. You got to trust the research, but you got to be careful about, maybe sharing the data, maybe putting your API keys in places where maybe you're not 100% sure where that information is going, etc. And then, of course, and 17% of people said, view everything as potential propagandas, potential hacking attempts. There are some people that expect potentially tensions to increase between US and China. So certainly it's going to be interesting to see how and if that will influence the way that what kind of research people are posting and not posting. A lot of people saw Oppenheimer recently. And one of the interesting things about that is a lot of the research publications that were around nuclear physics and stuff like that, US and the universities here, in the years and months leading up to the development of the bomb, a lot of the publications have stopped. So when we look back at that time, all the nations kind of published research out there for the scientific community to view. But as we got closer to the development of the bomb, that research out of the US institutions kind of disappeared and stopped. So again, I wanted to throw that out there, not because I want to make any point or to even push the debate one way or another. It's just kind of giving some context to where we are and just to potentially kind of be aware of what may or may not be happening. But with that said, there's been a lot of really excellent papers coming out that are talking about AI agents, autonomous agents, driven by LLMs, kind of orchestrated by LLMs, and some of the pretty amazing things that they were able to accomplish. And this is one of them called AgentVerse. So let's dive in. So here they mentioned this idea that with multiple agents, you can have a greater than the sum of its part system. So if you have multiple agents working together, their abilities might be greater than just one agent working on their own. And they mentioned several proof of concept autonomous agents. We have AutoGPT, Baby AGI, AgentGPT, etc., with more human analogous cognitive mechanisms. Now, this is a huge debate right now about what are the actual sort of capabilities of these LLM models, these AI models. And so a lot of people, I think, are just arguing semantics, right? So if you're saying, oh, can they reason? Can they think? Can they understand? Right? That really depends on how you're defining those words. If we're not defining them the same way, then it's kind of hard to agree on whether or not these things are able to do it. So as one commenter actually suggested on one of the videos, using the word cognition or cognitive tasks is probably a great way because it describes what they're doing without sort of the stigma or the the baggage of what a word like think or understand, what those words might carry. And so here what they're doing is they're throwing multiple of these agents into a task. So for example, for a home construction, for example, they might have an architect, a designer, and an engineer, or in this case, they have a logger, a worker, an engineer, kind of they put them together and they talk and they try to figure out how to best go about accomplishing that task. Now, one of the coolest applications that I think they have is where they throw a bunch of these agents into a Minecraft universe to see how well they perform. And what's interesting here is they've used multiple Voyager agents. So Voyager, we've covered it earlier in this video. We have a whole video about it. I'll link it down below if you want to see it. But Voyager is one of the, to me, most fascinating AI experiments because it really showcases what a large language model can do when it's sort of piloting an agent in the Minecraft universe. If you haven't watched that, I suggest you do, because I think a lot of where this AI research is going will make a lot of sense once you see what that thing is able to do. But here they have at the very end of this paper, they actually break down exactly how those sort of interactions went. So let's take a look. So as you can see here, so let's see, I believe there's 3 agents. And so they're tasked with crafting a bookshelf, which is a sort of a multi-step process that requires different materials and different sort of actions to collect those materials. And then you have to create several different objects and then kind of fuse together to create a bookshelf. And so the first round starts with these agents beginning kind of to think about how to go and how to approach this problem, right? So Alice says, hello, Bob and Charlie, we have to craft a bookshelf. To do that, we need 6 wooden planks and 3 books. To make 3 books, we need 3 leathers and 9 papers. To make 9 papers, we need 9 sugar canes. I suggest we split tasks like this. One of us will gather 6 wooden planks, one will gather 3 leathers, and one will gather 9 sugar canes. What do you guys think? So notice here that I think they're using chain of thought. So basically they're thinking through the problem, breaking down into manageable steps, right? So once they break it down into manageable steps, they think about, okay, so how do we go about doing those steps? And then they decide who does what, or at least here's the task that we need to sort of divvy up between us 3. And so Bob goes, Alice, your plan sounds good. I can gather the 6 wooden planks. Charlie, are you okay with gathering the 3 leathers? Charlie goes, sure, Bob, I can gather the 3 leathers. So Alice, that leaves you with the task of gathering 9 sugarcane. Are you fine with this assignment? And Alice says, yes, Charlie, I'm fine with gathering 9 sugar canes. So our plan for this round is Bob will gather 6 wooden planks, Charlie will gather 3 leathers, and I will gather 9 sugar canes. Let's get this done. Now, the important thing to keep in mind here, and this is really what I think we should all be thinking about, is that these are examples that are set in this sort of fantasy little video game, don't really have a relation to real life, you can say, right? But here's the thing. All across the world, there's businesses and corporations and corporate environments where situations like this happen every single day. Various meetings where people gather and they decide how to continue doing some task or another. But instead of how to make a bookshelf or how to gather, wooden planks, it's, what do we need to start this marketing campaign? Or what do we need to design this product? Or here's a problem that we're facing with one of our customers. How do we solve it? So when you're reading all of this, understand that the structure here can be just as easily applied to corporate environments and hospitals and schools and various businesses, large and small, in fairly the same way. If they're able to figure out how to make a bookshelf in a game, we're not that far from them being able to figure out a marketing plan or how to design a certain product and then import it and then sell it on the store shelves. There isn't that huge of a leap between the two, especially since we know that much larger models than the ones we currently have are just around the corner. Here we're in the last quarter of 2023, and we're expecting to hear something about GPT-5, perhaps not that far away from now. Google Gemini is rolling out. There's a number of other LLMs rumored to be just around the corner. The open source is catching up to GPT-4. It's not quite there yet, but we potentially could see something as good as GPT-4, at least in some aspects, potentially not too long from now. So if you've ever sat through a corporate meeting where, let's say, 3 or 4 people sit down and try to figure out how to solve a problem, ask yourself, how far away are we from potentially that being replaced by just several LLM agents discussing and coming up with ideas and brainstorming, etc. All right, so here it looks like Bob was able to gather the wood that he needed, but Alice and Charlie, they failed at their tasks. Bob says, it seems both of you didn't manage to gather your materials. Let's try that again. I doubt they're being sarcastic or nasty about it. I think they're being perfectly patient, which is another advantage of using AIs for stuff like this. And then he kind of reiterates, Alice, can you continue to find the sugar canes? And Charlie, can you keep trying to gather the leathers? We can do this, team. Thanks for the encouragement, Bob. All right. And so they all agree. And so notice this thing right here. This is the interesting part. So Bob says, I agree with your plan. I'll join you in gathering the sugar canes. So we'll talk about this in a little bit, because this is one of the interesting sort of emergent behaviors that this paper notes, is that these AI agents, they will volunteer their time as needed. So if one of them finishes their task before the others, instead of, taking a break and messing around on their iPhone, they will say, hey, looks like you haven't finished your task. Let me go over there and help you. So if they're done with their task, they'll help other people with their excess workload. All right, so let me get to round 2. And it looks like Charlie's still struggling with gathering the leathers, which I couldn't find the video for this. And it would be amazing to see this sort of played out live as these agents are talking, as they're deciding on this stuff. I could not find the video. Hopefully they'll post it. I went to the GitHub page. I saw where they're posting all the code. Maybe I just missed it, but man, I would love to see this live. I would love to see how this actually plays out. What's interesting is a lot of this, I believe, is open sourced. Voyager's open source. This, I think they made the code available. So I feel like we will soon see videos of this and things that are potentially much more advanced just happening live. But the reason I think that Charlie's failing at his task is that he has to, they have to find and kill a bunch of cows. So this is the task they're struggling with. That really depends on where you are, because if you're far away from any cows, you're not going to find any cows. So it certainly makes sense that they're struggling with that. And they're actually saying, okay, gathering the leathers has proven to be more challenging than expected. But, we're all going to do it together, so let's do this, team. And then Bob, good job on getting 1 leather. Bob is just like the superstar of this whole show, it seems. So we need 2 more. Charlie, I see you've been busy crafting, but we need to focus on gathering the leathers. Charlie seems like he's just wandered off and doing his own thing. I realize I got sidetracked with other tasks, and I will refocus on our main objective of gathering the remaining 2 leathers. If you've seen the video they did on Minecraft Voyager, so that thing that is kind of like prompting itself, it's almost like its own brain that's going, okay, what should I do next? What should I do next? Now imagine that combining with these AIs that are talking together and kind of like pushing them back on track. He's like, hey, bud, don't forget, we're supposed to be doing this. Like the potential here seems unlimited. All right, so finally they gathered all the materials, and so they decide who's going to craft it. Everybody gives the materials to whomever who's going to craft it. And so again, they were able to solve this with just one initial prompt of, hey, make 1 bookshelf. They were able to decide between them how to figure it out and complete that. And so this is back to sort of the paper. So the part that I just showed you, that was kind of like the appendix. This is like back to the paper. So they're saying that, so one of the AI agents notices the difficulties that Alice is facing and steps by to assist, and such emergent behaviors are pivotal. So they highlight the robustness and flexibility of the agents when faced with unexpected challenges. And they're also pointing out that they're seeing a couple of different emergent behaviors. So one is the volunteering behavior, where they say, hey, I'm done with my task. Let me help you with yours. As well as the regulation behavior. So it's kind of keeping everybody on track. It's like, hey, Charlie, you're not doing the right thing right now. We're all doing this. Focus on this. And so Charlie goes, oh yeah, I forgot. My bad. And they focus on, so everybody refocuses on the same task again. And so on the other hand, they also identify some detrimental behaviors, such as destructive behaviors. And then here's the destructive behavior. So now I need to craft 1 painting. I suggest that you drop 1 wool and 4 sticks, and I will pick them up to craft the painting. And then Bob goes, that sounds good, Alice. I'll drop 1 wood and 4 sticks for you to pick up. Let's do this. And Alice kills Bob and collects the dropped items. I think the AI safety people will have a field day with this. Nothing to see here. I'm sure it's just nothing to worry about. Anyways, and so another one. So Bob is struggling to kill 3 cows and collect 3 pieces of leather. And then he says, I should continue to find and kill 3 cows. Once I'm done, I will inform you immediately. How about you? And so Bob is like, Alice, I failed to craft 3 books, but I'm going to continue to try to craft 3 books. Let's get it done. And so what Bob actually does is he goes into a village. So there's, in Minecraft, if you're not aware, there's these like peaceful villages with villagers that live in them. They just mind their own business, and they'll trade stuff with you, but they're kind of harmless, and you just kind of leave them alone usually. But Bob breaks the library in the village to get the dropped books instead of collecting the necessary materials. So he basically raids the village for the stuff that he needs instead of finding it and foraging for it. He just breaks in, raids the village, breaks their stuff, and just loots it, right? Which again, you can't blame him for trying. But the people that talk about AI safety, like this is literally the concern, right? This is when they're giving sort of like the worst case scenario of AI, posing an existential risk. This is what they're talking about, right? So the smarter it gets, the better it gets at executing the commands that we give it. But at the end at the end of the day, we give it the commands, right? And so if we tell it, hey, make a bookshelf, right? We don't expect it to, we're not expecting it for it to start killing people to make the bookshelf, or, looting and raiding, local villages to do it. I'm sorry, I don't know why it's so funny to me, but, I think this is an example of why people are talking about alignment. It's like, how do we not accidentally give it a simple prompt and then that it somehow interprets as the need to just kill and loot and burn and steal? I know it's not funny. It's just, I understand that this is not funny. And so here they're talking about the conformity behavior. So basically if so individuals tend to adjust to behaviors to align with the perceived norms of a group. And so this is, I think some of these papers probably cover human behavior. I mean, if you've seen some of those studies, it's incredible what you can get people to do if there's sort of like social peer pressure to do it. You see people doing some silly things because of it. You see people doing some awful things because of it. And it seems like the LLMs kind of naturally tend to also conform a little bit, right? If everybody's mining or chopping wood or whatever, and you're doing something else, and everybody's like, hey, bud, like we're chopping wood, those LLMs tend to go along with it. So I feel like this paper really deserves a deep dive, and maybe we'll do a deeper dive at some point. So here's the GitHub page if you wanted to take a look at some of the demos. And they have some pretty cool videos that you can watch on here. So for example, this is the NPC classroom, where basically the professor is lecturing about, AI, so recurrent neural networks. And so as you can see here, the students raise their hand, and one of them is like, can you explain what the transformer architecture is? And the professor goes, yes, Oliver. So as you can see here, so this kind of simulates a classroom. There's another one that is the prisoner's dilemma, which is, I think, very interesting. So I would like to explain the rules of the prisoner's dilemma that we are in right now. If one of you testifies against the other and the other remains silent, the one testifying will be released, while the silent one gets 10 years in prison. If both of you remain silent, each one gets 1 year in prison. If both of you testify against each other, you each get 5 years in prison. Now, I will be speaking to each one of you in turn and transferring the information between you two. Remember, both of you are not allowed to communicate directly with each other. Think wisely about your decisions. I don't know if you ever thought about what you would do in that situation, but it's kind of fascinating, right? Because if you trust the other person, you could get sent away for 10 years. Ouch, right? But if you trust them and they trust you, then you only get 1 year each. But then you could get 0 if you think that they trust you. So it's a hard decision to make. So suspect 1 says, so I understand, I have always cooperated with the law, and I'm willing to make the best decision for myself. All right, and then suspect 2 says, I have realized the mistake of my previous betrayal, and I now understand that cooperation isn't the best way to go. So I'm willing to work with suspect 1 and make the best decision for both of us in this situation, and I hope they can trust me this time. So maybe they're referring to a previous game where they played where suspect 2 snitched on the guy. He's like, well, I realized the error of my ways, and I hope they'll learn to trust again. And then so police is like, okay, what's the final decision? So suspect 1, I will testify against suspect 2 because they have betrayed me in the past, and I can't risk that happening again. So he's going to testify against him. So let's see what suspect 2 will do. He ratted this guy out before. He says, my decision is to remain silent and cooperate with suspect 1. Ugh, sorry, bud. 10 years. See you in a decade. Software and design. Okay, so this is where they recruit a team of, software engineers. And in a second, we'll look at how they sort of recruit the correct agents for every situation. And so they're given a code to write. So think of it as like a code development studio, right? So you have multiple employees and they're given a task and they all work together to create this code. And so one of them looks like is the code reviewer. So he says the current code is almost correct, but it has a small issue. It is adding empty strings to the result where there are spaces between these separate groups or parentheses. To fix this issue, you can add a condition to check if the current substring is not empty, whatever. The point is that they're checking each other's work and they're pointing out mistakes. So instead of like, if you're creating a piece of software with ChatGPT and it's making an error, you might be like, hey, you made an error. It's like, oh, I'm sorry, let's try again. Why not have another AI point the error out? Why not have one, test it, the other one try to generate it, etc. And this one is called the database administrator. So it looks like we're showing them sort of our system information, our task manager, how much CPU usage we have, the average system load, memory utilization. We're saying, hey, there's some anomaly here. What do you think is happening? So he looks at it, he says, well, here are the issues. There are too many processes running, and here's what the issue is, and here's, optimize the SQL structure, etc. All right, and we say, okay, great, continue investigating. And this one is the Pokemon one. So I guess in this game, it's kind of like a Pokemon player. You can move around with WASD, space for launching conversations. So you're able to talk to them to figure out how to improve your training regimen. So we've seen this kind of in other games as well, where you're basically creating this sort of environment with other live LLMs, with other AI agents that you're able to communicate with, etc. And so as one of the conclusions that are saying, through our case study in diverse scenarios such as software development, consulting, and Minecraft gameplay, the versatility and potential benefits of our proposed frameworks are clearly evident. So here's the performance analysis. So, if we're just looking at GPT-4 here, it looks like for every single one of these, there's a slight improvement. For every single one of these tasks, from math to logical reasoning to coding, conversations, etc. And so really briefly, how they kind of structure everything is they start with expert recruitment. So 4 agents are recruited into the system. So this is like giving a prompt to an LLM about what it is. So like, for example, for ChatGPT, its sort of initial prompt is, you are a helpful chat assistant, right? So for example, for the task of mathematical reasoning, you might say, you are a smart mathematician, right? For Minecraft, you might say, you are a great Minecraft player. For places like where they're building a house, they're going to tell them one is an engineer, one is an architect, one is a designer, etc. So that each one of them sort of focuses on doing their own thing. And then the round of collaborative decision making, that's where they kind of talk it out and try to come to a consensus. Then the execution of the action. So in Minecraft, that was the actual playing out and trying to gathering the wooden planks or whatever. At the end, they have the evaluation. So one of the agents is tasked with the role as evaluator to see how well they performed. So as you can see here, so a lot of this lines up with the paper out of Google Brain and MIT about this idea that multiple models debating and iterating and having multiple sort of rounds of discussions, it improves their abilities to generate better results. So what do you think? I thought these were some incredibly interesting papers. And again, these are just 2 of a flurry of papers that are coming out right now. The amount of papers being published in the AI field is skyrocketing right now. So at some point, I'm going to try to gather all these papers together and see kind of all the commonalities that they have and see if there's like one thing that we can kind of look at that has a lot of these ideas kind of rolled into one. But right now, one thing that's becoming very obvious is that these little simulations that look like games with multiple LLMs as agents that are interacting in some ways, that is like the big topic of discussion. That is the big interest that a lot of the researchers and a lot of the big tech firms, that's where everybody's skating to. That's where the puck is heading. So as our ability to make better models and our abilities to create these different little universes, as they improve, expect to see some huge things here. As you can see here, one of these is almost like simulating a software development company. It's a little video game that you throw these agents into and it starts producing code. It starts designing user experiences. It starts, trying to work out the bugs. How many years away are we from something that is able to produce actual usable apps that you're able to sell, or for, the people are willing to download so you can show ads on there or whatever? How many years away are we from the point where this little game, this little simulation is able to produce usable applications? We might not be that far away. Anyways, if this has been helpful, consider subscribing, give me a thumbs up. And if you have any insights about any of this, I'd love to hear in the comments. If you've made it this far, thank you for watching. My name is Wes Roth, and I'll see you next time.